In 2023, climate discourse blew up with the news that 6 out of 9 planetary boundaries were being crossed, with all boundaries processed seeing an increase. This news was a wake-up call for everyone, that we may be pushing the boundaries towards irreversible changes to our environment. But what are the planetary boundaries, and why is crossing them so grievous? The Planetary Boundaries is a framework that identifies the limits of Earth systems for our environment to thrive. These limits are there for the environment to self-regulate, and the more we are pushing beyond these limits, the more our environment destabilizes, which may lead to catastrophic impacts on our biodiversity and ecosystem. These limits are called safe operating space, as they draw the extent to which humans' life can thrive. There are 9 planetary boundaries: climate change, biosphere integrity, land use change, freshwater use, biogeochemical flows, ocean acidification, aerosol loading, stratospheric ozone depletion, and novel entities. Climate change. What is climate change? Seems like a heavy-loaded question, but climate change is essentially the changes in our environment, in our ecosystem, and the world. Climate change is a natural recurring phenomenon caused by the exchange of energy between the sun and the earth. However, through the increased greenhouse gases and aerosols from the modernization of our society, energy has been trapped, causing global temperatures to rise and changing climate patterns. Climate change essentially has been reclaimed as man-made as it increases to unprecedented speeds, and it has pushed us beyond the safe operating space. Biosphere integrity. Biodiversity is crucial in regulating our ecosystem, and so biosphere integrity looks at the ability of the biosphere to regulate the balance of energy and chemicals. Think back in middle school, when you learn about the food chain. Losing one species means the entire food chain is lost. Biosphere integrity assumes 2 types of biodiversity: genetic biodiversity and functional biodiversity. Genetic biodiversity looks at the richness in the same species. Take humans, for example. On a global scale, we have a rich genetic biodiversity. Our gene pool is quite large. Inbreeding, on the other hand, has a small gene pool and therefore reduces the genetic biodiversity in that population. Inbreeding is bad, kids. Don't do it. In the animal and plant kingdom, we're looking at genetic biodiversity more and more as species fail to adapt the changing climate. Functional biodiversity is probably what you think of. Richness of different species and how they interact with each other. Having more and more animals and plants endangered will be losing functional diversity, which is why both are currently exceeding the safe operating space. Land system change, or land use change, is basically how our land and environment has changed from its natural form. What is land use change? Deforestation is land use change. Plowing the land for agriculture is land use change. Urbanization and building stuff is land use change. Transforming the land from its natural form diminishes the ecological functions, like acting as a carbon sink, soaking in water and regulating food, being home for wildlife to thrive. Globally, the remaining forest areas in all 3 biomes, tropical, boreal, and temperate, have gone past the safe operating space. Freshwater change. Firstly, take a guess on the percentage of freshwater we have on Earth. Go on, have a guess. If you guess 3%, you would be correct. More than 70% of Earth's surface is covered in water, and 3% of that is considered freshwater. And of that, a sixth of that water is available freshwater. The rest is not accessible to us as they're either locked up in glaciers, ice caps, or the soil, or polluted. The current state of freshwater change has shown that human-induced disturbances of blue and green water have exceeded the safe level. What are biogeochemical flows? They're the movement of key nutrients like nitrogen and phosphorus. It's the movement between the atmosphere, biosphere, pedosphere, and hydrosphere, air, land, soil, and water. This movement of nutrients, or nutrient cycling, plays a key role in supporting life and maintaining ecosystems. The fine balance of nutrient cycling is crucial for ecosystem balance, climate regulations, and food production. Ironically, one of the reasons why biogeochemical flows have been tipped out of balance is through the industrial man-made extraction of nitrogen from the atmosphere for ammonia, which is currently made into fertilizers. This then bears the question, why is our food production strengthening at the expense of natural food production? The ocean is a massive carbon sink. When atmospheric carbon dissolves into the ocean, it acidifies. This makes ocean acidification closely tied with climate change. It's also linked to biogeochemical flows, as is acidifying through the absorption of atmospheric CO2. With this increased acidity or lower pH, marine ecosystems are taking a hit as the environment changes. This leads to calcification, which erodes corals, shells, organisms, and planktons. Ocean acidification increases hydrogen ions, which react with carbonate ions, a key ingredient in building the calcium carbonate shells for these organisms. With carbonate ions displaced, corals and shelled organisms lose the ability to strengthen their shell. The indicator for ocean acidification is currently within the safe operating space, but is a little too close to the boundary for anyone's liking. Have you ever seen air pollution? Haze? Random particles in the air? This is exactly what aerosol loading tackles. Airborne particles released from man-made activities. Stuff like soot, sulfate, and nitrate aerosols can stay in the atmosphere for a while, affecting temperature, precipitation patterns, and human health. They are currently within the safe operating space. The stratospheric ozone layer is a godsend for us as it protects Earth from harmful UV radiation. It means that we're able to get outdoors and not immediately get skin cancer. Back in the 1980s, we found out that our atmospheric ozone layer is thinning due to man-made chemicals that react with ozone. Check the video on Montreal Protocol, which was a key driver in getting this planetary boundary within the safe operating space. Last but not least, we have novel entities. What are novel entities? Well, novel can mean new, and entities are just, things. So there's a planetary boundary for new things. How do we know what's considered new? Synthetic chemicals, microplastics, toxic metals, and nuclear or radioactive materials are under this category. New and evolutionary processes like genetically modified organisms, aka GMO, are accounted for in this planetary boundary. These elements and processes may have harmful environmental effects. At the moment, we're releasing these materials into the environment beyond the safe operating space, largely due to the lack of testing of these materials to environment and human health before it's released. Well, doesn't all this seem highly theoretical? What's it for me, and why do I need to know? The planetary boundaries might sound too policy heavy, but it is great use to us knowing what our limits are. Just like the UN Sustainable Development Goals, this is a great tool in your day-to-day decision making. Does this habit drive aerosol loading? Does my work affect the biodiversity? What can I do to work towards the safe operating space? The planetary boundaries, in my opinion, is a way better indicator than the SDGs when it comes to environment and climate protection. The SDGs only have 3 relevant goals: climate action, life underwater, and life on land. But this puts it all into perspective. It integrates all parts of climate and the environment into these 9 boundaries. And as much as it can and should be looked at it as a whole, it also divides it into reasonable topics, so it's less overwhelming to focus on one and take action. And action is what we need right now. Preferably not in Minecraft.